Greetings. Welcome to Introduction to SQL Programming for Excel Users, Part 4, Basic Selects. I am your instructor, Dave Langer. As I like to do with all the videos in this series, a little bit of housekeeping is in order to begin. First of all, if you do not have SQL Server, if you do not have the database and the database engine needed for these tutorials, please check out these two videos here on my YouTube channel. This one shows you how to install SQL Server for free on your local laptop or desktop if you are a Windows user. If you are not a Windows user, or for some reason you don't want to use a local machine, this video will tell you how to get everything set up in Microsoft's cloud, which is called Microsoft Azure, for free for the duration of this tutorial. Next up, all of the files for this tutorial are located on GitHub. The link to this GitHub is in the description for this video. It's github.com/daveondata/SQL for Excel users. And in this GitHub, you will find all of the files for this YouTube tutorial. Here I am in the Excel file corresponding to this part of the video tutorial, SQL for Excel users part 4. And I'm on the Selecting Data worksheet. And what you can see here is something that's commonly done with Excel, which is you'll notice that there's a bunch of columns that are hidden. And that's often done in practice with Excel, especially when you're sharing a workbook across maybe different people on a team or maybe between teams in an organization. Oftentimes, the person that you're sending the Excel workbook to doesn't need to look at all of the columns. So what you do for them is you pre-select which columns of data you would like them to see. In this particular case, I have selected wage type, shift, level 1 operators, level 2 operators, calls, and date. I have selected those columns from the call center table. Now, conceptually, this is done all the time, as you might imagine, in SQL. You select data because oftentimes tables in a database, in a relational database, have a huge number of columns. And most of the time, you're not interested in all of them. So I pull back all of that extra data. So selecting columns that you want is a core aspect of writing SQL queries. So let's go ahead and flip over to SQL. All right, here I am in SQL Server Management Studio, SSMS. And you can see here our database that we're using in this tutorial series, AdventureWorks DW 2017. If I open this up and I take a look at the tables, for this particular video, we're going to be looking at this table in particular, Fact Call Center. Now, if I open this up, I can also open up the columns, and you can see there's a large number of columns available to me in Fact Call Center. For the purposes of this tutorial, for this particular scenario, I am not going to use all the columns. I'm going to select only the columns that we saw in the Excel spreadsheet. But what I'm going to do here is explain how you write our first full SQL query in a logical sequence, in a conceptual sequence. Because when you write SQL, it's very intuitive once you get the hang of it. However, one of the things that trips people up in the beginning is SQL isn't processed in exactly the same order in which it is written. So what I'm going to do is I'm going to build the query up step by step in the logical, in the conceptual order in how SQL actually runs the code that you write. The first thing that happens is you will tell the database engine via your SQL which table you're interested in getting the data from. So right here, you can see I'm telling SQL, hey SQL, I want to pull data from the Fact Call Center table. This is logically the first thing that is processed in a SQL query. Now you'll notice there's this little red squiggly of death here. Now, if you hover over it like I'm doing here with the iBar and SSMS, it's going to give you its best guess as to what the error is. A red squiggly of death tells you that you've got a problem in your SQL code. Now, we know what the problem is here. A from Fact Call Center, that is a fragment of SQL. It's not a legit full piece of SQL. It's only a fragment. So of course, SSMS is going to give us the red squiggly of death and say, hey, Dave, this is not good. This is not kosher. This is bad juju. And I say, okay, no problem, SQL. We'll fix it up later on. So if we scroll down, the next thing we can take a look at is this idea that it's very common practice in SQL to provide an alias, a quote unquote alias. Think of this as a nickname, because I don't want to necessarily have to write fact call center everywhere in my SQL query. So what I can do is I can provide a shorthand notation, an alias. Now we'll call this FCC, and this is very commonly done in SQL code, because as we'll see in a bit, oftentimes you might have tables where you have table A and table B, and they both have a column of the same name, and you need to differentiate one from the other. And how the easiest way to do that is with an alias. You can use the full table name if you want, but why type all those extra characters if you don't have to? So throughout this tutorial series, you will see me use aliases rigorously in my SQL code in this tutorial. And if I don't, it's because I made a goof. And if I do that, I apologize. So here we have an alias from fact call center FCC. Okay, so here's what's happening behind the scenes conceptually. This is the first thing that SQL looks at, the SQL server, the database engine looks at. It says, okay, hey, Dave wants to pull data from the table named fact call center. Oh, but he also wants to give it an alias. He wants to give it a nickname. So I'm going to be smart. So anytime in Dave's query I see FCC, I'm going to say that translates to the actual fact call center table. Okay, this is goodness. So next up, we can select all of the columns very easily using this asterisk. This is what is known as the wildcard. This literally tells SQL, hey, from the fact call center table, which I want to be aliased as FCC, please select for me all of the columns in the table. And all the columns would be all of these over here. Now, this is considered bad practice. This is considered shorthand notation. It's kind of hacktastic. Generally speaking, you don't want to write your production code using the wildcard, but it is legit. This right here is a legit piece of SQL, because notice there's no red squiggly of death anywhere. So I could highlight this like so, and click execute in SQL Server, and lo and behold, I get back all 120 rows of data, all the data. I get all the columns and all of the rows. Now here's the thing. Strictly speaking, the logical processing doesn't go from to select. Typically what actually happens is first you tell SQL, hey, this is the database table I want you to pull data from. And then the next thing that the database engine does is look at your filter. So it says you want to pull all the rows, but then I'm going to filter them down. Now, since we don't have a filter here, that step is skipped, and then it goes to select. So it goes from to your filter, and then from your filter to your select. Now we're going to modify this conceptual processing hierarchy as we go through the tutorial, but we're going to start small and build from there. So for right now, the logical processing order is from which table you're interested in, filter the rows down, and then what columns do you want. That's the logical processing order. So we can go ahead and get a little bit more jiggy with it here and say, okay, it is not good practice to use the wildcard. You should explicitly choose which columns you want out of the database. That's considered good SQL coding practice. So what you can see here is exactly what we would expect. Select FCC.wage type, shift, level 1 operators, level 2 operators, calls, date, so on and so forth. So if I run this piece of code, now we get something that looks just like our Excel spreadsheet here. So all the same data, all the same data. This is goodness, okay? Sweet. For the next step, let's go ahead and flip back over to Excel and filter this data down a bit. Okay, back again in handy dandy Excel. I'm in the SQL for Excel users part 4 file, which is available from the GitHub. And what we want to do now is we want to filter down this data. So we're going to use a filter that we talked about in video 3 of this tutorial, which is we're going to use a combination of filters on column D, or the shift column, and level 2 operators, or column F. Specifically, what we're going to do is we're going to implement a filter that says, look, in the shifts, I only want the values where shift is equal to PM1, or the value is equal to PM2. If I click OK, we go ahead and narrow it down. And then next up, we want to take a look at the level 2 operators where they are less than or equal to 10. So we go ahead and use our handy dandy GUI here in Excel, and we can place these filters. So what we have here is a multi-column, multi-condition type of filter situation. As you recall from the previous video, video 3 of this tutorial, we can actually think of this conceptually using a textual representation, which I have right here. So this is a conceptual representation using text of the Excel filter. You can see here, I'm looking at the call center table because in Excel, the table is just referred to as call center. So call center.shift, the shift column of this table, needs to be equal to PM, or the shift column needs to be equal to PM2. Now, since we added a secondary condition, a secondary filtering condition, we have to put an and in here, right? Because this is one logical group. This is a filter on one column, logically speaking. Is shift equal to PM1 or is shift equal to PM2? And we've also added a secondary filter that says, okay, I want to see where call center call center level 2 operators are less than or equal to 10. All of this together produces what we see here, which is 36 rows of the 120 records. Okay, so what we have here now is a textual representation that describes what's going on in Excel, but it also maps very, very well to SQL. So let's go see how that mapping works in practice. Alrighty then. So here I am back in handy dandy SQL Server Management Studio, SSMS, and now we have our full query. And you can see here is the filter representation. And notice how it aligns almost exactly conceptually to what we have here from this text where we were mimicking the conceptual idea of how filtering was happening in Excel. Notice that all we needed to do was just replace call center here with FCC, and we replaced double quotes with single quotes because that's the way SQL works. It uses single quotes, not double quotes. But generally speaking, check this out. I mean, this is all basically the same conceptually. I mean, it's very, very simple to just map this when you think of what Excel is doing behind the scenes in a textual sense, to map it to SQL. Very, very simple. Is the shift equal to PM1 or PM2? And is the level 2 operators less than or equal to 10? So I can highlight this whole query and run it. And we get back 36 rows of data, just like we did in Excel. Okay, now we have our first full query of the tutorial. And this is far from the last, by the way, but this is our first full query. So now we can start thinking about how SQL operates, as I mentioned earlier. Notice that it isn't processed in the same way SQL is written. Notice that you write the select first, but in fact, in this particular query, the select is actually handled last. Now, just some terminology here. This is what's known as the select list. So if you ever see that term or you hear me say it, you know what I'm talking about now, which is like essentially all of the columns that are part of the total select logical operation of the query. And as we'll see in later tutorials, the select list can be quite complicated. You can do a lot of really cool and interesting things inside the select list, which is why we want to have a term specifically designated for the things that we're selecting in our queries. So even though you write the select and the select list first in terms of the syntax of SQL, it is actually processed last as part of this logical query. So now that we have the full query, let's just walk through it one more time. If you've already got it, I apologize, but this is super important stuff to understand how to work with SQL, and thinking about it in terms of its logical processing is extremely important. This whole query gets processed thusly. First up, we tell SQL, hey, I want you to pull data from the fact call center table. And I would like you to use the alias FCC. So anytime in my query you see FCC, just map it to the actual fact call center table, this thing right over here. That's the first thing. So SQL says, okay, cool, I'm going to go to the fact call center table, And if you don't provide me any predicates, if you don't provide me any filters, which we put in a where clause, as you see here, then I'm just going to return you back all the data. But lo and behold, we have applied filters. Filters in SQL are applied using the where clause. As we'll go on in the tutorial, there are other places where you can filter, but for our purposes right this second, in this stage of the tutorial, you always do your filtering in the where clause. And how you filter, as we talked about in the last video, is by establishing predicates, by writing predicates out as part of the where clause. So what happens is SQL says, okay, cool, Dave, you want to pull data from fact call center with an alias of FCC. Oh, but you want to filter the data. I see that because you have a where clause here. And these are the things you want to do. First up, I've wrapped my predicates in parentheses, which I mentioned last time in the last video in part 3 is a good idea, especially when you first start out. The order of precedence rules for filters are complicated. And so when you first get started in SQL, it's just a good rule of thumb, I find, to say, look, when in doubt, just wrap things in parentheses, and then you'll know they'll be processed as logical groups, logical predicate groups. So what I'm doing here is I'm telling SQL I have 2 logical predicates. This one, right, wrapped by parentheses, and I've got this one right here, also wrapped in parentheses. And SQL says, okay, cool. I've got 2 predicates. I will process them individually. So first up, it says, okay, I'm going to filter down all of the rows in FCC or fact call center to where shift is equal to PM1 or shift is in PM2. So you can literally think in your mind of it just filtering down those rows. Now, behind the scenes, that's not exactly how it works, but logically it's sufficient for our needs. So we filter down all the rows to only those that have PM1 or PM2. And you can actually look at it this way if you want to by just highlighting the query like so. We're just saying, okay, I'm going to just logically process this predicate by just running the query like this. And you click execute. And the first thing that comes back is 60 rows of data. Okay, so out of the 120 entire rows of data in the fact call center table, what we have here are 60 that have a shift value of PM1 or a shift value of PM2. Sweet. Now we can also then say, well, let's incorporate the second predicate here. And if we run that, then we get 36 rows. So what we know is 24 of the 60 rows that we saw earlier have level 2 operators at a value of 11 or more. Now, if you're really interested, one of the things you can do is you can also say how many rows are just this, right? Just this predicate. Now, the problem is that syntactically, this is written before this. So an easy way to hack up your code just to do this is to put in what's known as a comment. And these are comments right here. You see they're in green. And how you designate a single comment is with just double dash. So if I do this, boop, boop, notice that this all turns green. And what happens is that as far as SQL Server is concerned, it doesn't exist. I've effectively commented out, that's geek speak, I've commented out this particular predicate. And now I can highlight this and I can say, look, I'm just interested in finding all the rows where level 2 operators are less than or equal to 10. So you just go ahead and run that, and you get back 96 rows. Okay, now this is interesting, right? Because you know from before, there are 60 rows in the table that have PM1 or PM2, but there are 96 rows that are less than or equal to 10. But if you put both of these predicates together, you only get 36 rows. There you go. Okay, so once again, starting from the top, hey SQL, I want you to pull data from the fact call center table. I want you to use the alias of FCC in this query for that table. And I also want you to apply 2 predicates to it. And SQL says, okay, cool. It goes to the table. It grabs only the data that matches all these predicates that we provided, which is 36 rows of data. We then tell SQL, hey, look, we don't want all the columns. We just want you to use this select list for the data. And that produces the results that you see here. There you have it. Easy peasy. Your very first fully functioning SQL query. I hope you enjoyed the tutorial series. There'll be 2 videos a week until I catch up with my blog series. Feel free to subscribe if you like what you see here. And until next time, I wish you very, very happy data sleuthing.